Welcome to myprojectbazaar.com. Now let's see about noise reduction based on partial reference dual tree complex Wavelet transform shrinkage. Now let's see about the abstract. Here we propose a novel method to reduce the noise from the image. Initially we have to generate the Gaussian noise to the input image. So Gaussian noise is the statistical noise that has its probability density function equal to that of the normal distribution, which is also known as the Gaussian distribution. After generating noise, dual tree complex Wavelet transform is implemented. So the complex valued extension to the standard discrete valued transform, it is applied to the decompose the image. It has the added characteristics of perfect reconstruction at the cost of approximate shift invariance. After Wavelet transform, we apply this shrinkage method to denoise the signal. Then we take the inverse Wavelet transform to reconstruct the image. So this will be the final denoised result. So after that we analyze about the denoising by calculating the PSNR and MSE values. This is the flow of our process. Here we have to given the input image. The input image will pass through the pre-processing step. In pre-processing, we generate the Gaussian noise to the image. Gaussian noise is the statistical noise that has its probability density function equal to that of normal distribution. In other words, the value of the noise can take on or Gaussian distributed, so that the generated noise will pass to the discrete complex Wavelet transform. So it will transform the image to the coefficients. It is a two-dimensional Wavelet transform which provides a multi-resolution sparse representation and useful characterization of the structure of an image. It calculates the complex transform of a signal using two separate DWT decomposition such as tree A and tree B. After that it will go to the shrinkage function. Here we using the overlapping group shrinkage. It is the thresholding technique. Based on the overlap group shrinkage, the noise threshold will be identified to the coefficients. After identifying that, it will be removed from the coefficients. After denoising this, it will pass to the inverse dual tree complex Wavelet transform. Here we are reconstructing the DWT coefficients as an image. After inverse transform, we are getting the denoised image. For the denoised image, here we are analyzing about the quality such as PSNR and MSE values. Now let's have a demo of our process. Here I am having main.m file. Select this file, right click and run the file. So this is our guide design. So we have to given the input image. So this is the input image. We are giving, I am selecting one image as input. This is the selected image. For that it will pass to the noise generation. So these are the generated noise to the input image. For the generated noise, we estimate the image quality. So the MSE and PSNR values are 25 here. This is the comparison between the original and noisy image. After that it will pass to the next process. Initially we are identifying the complex Wavelet dual tree transform. This is the result, such as horizontal, vertical, diagonal, directional result are identifying. After that overlapping group shrinkage is applied. So the noise is removed from the coefficients. So now OGS task is completed. After that it will go to the inverse complex Wavelet. So this is the denoised result of noisy image. This is the noisy image, this is the denoised image. After that we are analyze about the PSNR and MSE values. Here we are showing the result of MSE and PSNR values. It is the image quality is improved in the complex dual tree Wavelet transform. Thank you.